Hello, my dear friends. Welcome to the subject of statistics for the class 12th English medium, the part 1, chapter 2, the linear correlation by Vidhan Sir. Today, we will be solving the exercise 2.3 of this chapter. Starting with the first question. Exercise 2.3, the first question is for 6 companies, 2 analysts have given them rank based on their market analysis. The analyst number 1 has given the ranks and analyst number 2 has given the ranks. That means in this question that ranks are given directly. When the direct ranks are given, we just write them down, whatever the data is available. And once we write down these ranks, we have to prepare two other columns, that is the D and D square. D is the difference between the ranks, like this. These are the differences of the ranks, and then we have to square these differences of the ranks. Once we square the differences, we make the total. Of course, the total of the D column is 0 and the D square column is 18. So now we have to use this total 18 in our sum. We will start with the formula, and the formula is 1 minus 6 summation D square upon n into n square minus 1. We will put the values. D square is 18, n is 6. That would multiply into 108 upon 210. That would be 1 minus 0.5143. That is 0.4857. The round figure value is 0.49. So the answer is 0.49. That means the value of R is near to 0.5. So we can say that there is a moderate degree of positive correlation. That implies that ranks of two analysts are loosely the same. That means they are not exactly opposites, but they are not that much perfectly correlated. Okay, so that is moderate degree of positive correlation. Moving on to the second question. An official has ranked 9 villages of a sample on the basis of the work done in the area of Swachhata Abhiyan and Beti Bachao Abhiyan. The ranks are available from 1 to 9. We have the ranks directly, so we just need to write the 4 columns Rx, Ry, D square. Write down the data according to the X and Y columns. Rank for Swachhata is X, rank for Beti Bachao is Y. Once you write down the ranks, make a difference. After writing down the differences of the ranks, make a square of all the differences and then make a total. Once you are done with the total, as usually, start with your formula 1 minus 6 summation D square. Divide by n into n square minus 1. That is 1 minus 6 into 26 upon 9 into 9 square minus 1. That is 1 minus 156 upon 720. That is 1 minus 0.2167. That is round figure 0.78. So once you are done with the answer, write the statement that the value of R is near to 1. So we can say that there is a high degree of positive correlation between the performance of two works done in the village. That is the Swachhata Abhiyan and the Beti Bachao Abhiyan both are progressing in the same direction, very much near to perfection. They are going side by side is what we can say. The third question, now from this our main work starts, is the ranks are not given but the quantitative data is there. This is a survey conducted of 5 cities with the population and the rate of growth of the population, and we have to check whether it is positively correlated, negatively. What is the rank correlation coefficient between these two data? First of all, we will write down the data and then we will find the ranks, and after we have found the ranks, we will start with the difference and the squares. Start with these columns: city, A, B, C, D, E, the population, the rate of growth, and once you are done with that, we will start giving ranks. Now for the population, the highest value is 57, so that would be rank 1. The next highest is 45, so that would be 2. The next highest is 18, then comes 14, and then comes 8. We will move forward to the rate of growth. The highest is 20, then it is 15, then it is 13, then it is 10, and then it is 5. So now you are done with your ranks. So you get your Rx and Ry columns, and once you get your Rx and Ry columns, we are ready for our D and D square columns. Our D column will be -2, 1, 0, 1, 0. Now, as usual, the business, whatever we have been doing, the difference between the two Rx and Ry. Once we are done with the D, we will write down the D square. So that is your usual thing. You have to only make a total of the D square. You don't need total of anything else. Just make a total of D square. We will start with our formula. R is 1 minus 6 summation D square upon n into n square minus 1. Putting the values, multiplying with the values, dividing, and you will get your answer. So we will say that the value of R is near to 1. So we can say that there is a high degree of positive correlation between population and rate of growth. Simple, right? Moving on. Question number 4. In this question, a sample of 10 students and their marks in mathematics and marks in statistics is taken, and we have to check whether these two subjects for these 10 students are correlated or not, and if it is, then what is the degree, what is the type. So as usual business, we will start with writing down the number of students 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then we will write down the marks in the mathematics subject, all the marks. We will write down the marks in statistics subject. We will start with ranking mathematics subject. The first rank will go to 98. Then it will be 90. Then it will be 82. Then 78, 75, 65, 62, 39, 36 and 25. So these are the ranks of the mathematics. Likewise, we will give ranks to the statistics. The first rank will go to 91 marks, then comes 86, then comes 84 marks, then 68 marks, 62 marks, 60 marks, 58, 53, 51 and 47. So these are the ranks of the statistics subject. Now we have to prepare the D and D square. The D will be the difference between all the ranks of the mathematics and statistics. We already know how to do this. Once we are done with the D, prepare the D square. Square all the D column values. Once we are done with the D square, make a total of the D square. So the total of D square here is 30. Write down the formula 1 minus 6 summation D square upon n into n square minus 1. 1 minus 6 into 30, 10 students, so 10 into 10 square minus 1. 1 minus 180 upon 990, that is 1 minus 0.1818, that is 0.8182, that would give us 0.82. The statement will be the value of R is near to 1, so we can say that there is a high degree of positive correlation between marks of statistics and mathematics subjects. So there is a very high degree of positive correlation. Starting with question number 5. Now here the height of husband and height of wife is given, and we have to calculate the rank correlation coefficient between the heights of husband and wife. Now before we move forward, just check the data. In the height of husband, all the values are unique, but in the height of wife, can you see some repetitions? Yes, 162 centimeter has been repeated twice and 154 centimeter has also been repeated twice. So there are two ties in our observations. And whenever there are ties in our observations, we have to calculate the correction factor. So for that, you will need to create this table. Similar observations, number of repetitions, and the correction factor, that is m cube minus m upon 12. The first repetition is 162. Number of repetitions are 2. And so our correction factor will be 2 cube minus 2 upon 12, that is 0.5. The second repetition is 154 2 times, so 2 cube minus 2 upon 12 is 0.5. Only two observations have been repeated twice each, so the total correction factor will be 1. At the time of using the formula, we will put this one, we will add this one in the total of the D square column. We will start with the height of husband, height of wife. Write down the observations as it is. Now we have to start with the ranks. For the height of husband, the highest value is 191. Then comes 185. Then comes 163, 162, 157, 56 and 53. So likewise 1 to 7 ranks are allotted. Now at the time of height of wife, we have two ties here. So we will keep that in mind while assigning the ranks. The first rank will go to 170. Second rank should go to 162, but there are two 162s. That means second and third rank will be allotted to 162, 162. So we will take an average of the second and third rank, that is 2 plus 3 upon 2. The answer is 2.5, 2.5. So we will not write 2 or 3, we will write the average, that is 2.5, 2.5. So now ranks 2 and 3 are over. The next rank is rank 4. After 157 comes the 154. That means we have to assign 5th rank. But there are two 154s. So we have to assign the ranks 5 and 6. As there is a tie, we will take an average of 5 and 6. That is 5 plus 6 upon 2. That would be 5.5, 5.5 each. So we will assign 5.5 to 154 both the times. 5th and 6th ranks are over. The next is the 7th rank. So this way we have ranked each and every value of the height of the wife. Once we are done by assigning ranks, we will write down the D and D square columns. Find the differences of the ranks. Be very careful in this process. Once we are done with the differences of the ranks, we will make them squares. After that, make a total of all the squares. The value is 4. Start by writing down the formula. The formula will be a bit different, that is summation D square plus CF will be there in the formula. You will write down the value 4 plus 1 and 7 observations are there. So that would be 6 into 5 upon 336, 30 upon 336. Then 1 minus 0.0893, that would be 0.9107, round figure 0.91. Using this value we can say that the value of R is near to 1. So we can say that there is a high degree of positive correlation between heights of husband and wife. So as you can see, the heights of husband and wife are highly positively correlated with each other. The next question, number 6. The marks by first interviewer, marks by second interviewer. There are almost 8 candidates. 2 interviewers are there and they have assigned marks to all of these candidates, and we have to check using the Spearman's rank correlation method whether they are correlated, what type, what degree. For that, by checking the question, you can see certain values have been repeated. So for that, similar observations, number of repetitions and the correction factor. If you see the value which have been repeated, you can see that in the first interviewer 28 has been repeated twice, for which the correction factor will be 0.5. For the second interviewer 32 has been repeated thrice, for which the correction factor will be 3 cube minus 3 upon 12, that is 2. 3 cube is 27 minus 3 is 24 upon 12 is 2, and the total of this 2 will be 2.5. At the time of the calculation, we will use this correction factor into our sums. We will start by writing down the data. The number of candidates are A, B, C, D, E, F, G, H. The interviewer number 1, his marks. Interviewer number 2, his marks. We will start by ranking them. The interviewer number 1, the first rank goes to 47, then comes 44, then comes 40, then comes 35. After 35 is 28, which is twice the rank 5 and rank 6. The average of these two is 5.5, 5.5. So after 6 comes 7 and then comes 8. Once we are done with ranking interviewer 1, we will start with interviewer number 2. The first rank goes to 45, then comes 41, and then comes 38. Now the next is 32, 32, 32, that is 4, 5 and 6. So we have to take the average of these three, the 4th rank, 5th rank and 6th rank. So make a total and divide it by 3, because 3 observations are there, and your answer will be 5. So we will assign all the 3 the rank 5. After 4, 5 and 6, the next is 7 and then 8. This way you have assigned ranks to each and every observations. Once you are done with this, write down the D and D square column, find the differences of all the ranks, make their square and make a total of the square. Once you are done with this, write down the formula and add the correction factor into our formula. Write down the value, that is 5.5 plus 2.5, and 8 observations are there. So that would make it 6 into 8 upon 8 into 63, that is 48 upon 504. That would be 0.0952, and deduct it from 1. The answer will be 0.90. The statement will be the value of R is near to 1. So we can say that there is a high degree of positive correlation between marks of both interviewers. That is, marks given by both the interviewers has a very high degree of positive correlation. The 7th question, it is a simple one, because the sum of squares of differences of the ranks given by 2 judges to 10 contestants is found to be 214. As we know that the sum of squares of differences in the ranks mean summation d square, and which is equal to 214. That means summation d square is directly given, and n is 10 contestants, that is n is 10. So we will start with by writing down the formula 1 minus 6 summation d square upon n into n square minus 1. That would be 1 minus 6 into 214 upon 10 into 10 square minus 1. That would be 1 minus 1284 upon 990, which is 1 minus 1.297. We will get a negative answer, negative 0.297, and round figure negative 0.3. It is okay even if you don't write a statement for these short questions, but if you want value of R is near to 0, therefore we can say that there is a low degree of negative correlation between the ranks assigned by the 2 judges to 10 contestants in a beauty contest. Moving on to the last question of the exercise, which is about the correction. There are 10 students, the rank correlation is 0.5. It was found afterwards that we have taken a difference of 7, but it was to be taken as 3. So now we have to find the corrected value. Now first of all, n is 10, r is 0.5. So we will start with the finding incorrect total of the squares of the differences of the ranks. Put the formula and put the available values in our formula. R is 0.5, 6 summation d square is as it is, n is 10. So 0.5 is equal to 1 minus 6 summation d square upon 10 into 10 square minus 1 is 990. Now change the side of the 6 summation d square upon 990, and it will be something like this, that 6 summation d square upon 990 is equal to 1 minus 0.5. So 1 minus 0.5 will be 0.5, while 6 summation d square upon 990, so cancel out 6 with 990 and you will have 165 in the denomination. Change the side of 165, so summation d square is equal to 0.5 into 165. Therefore summation d square is equal to 82.5, which is the incorrect value, incorrect total. Now you have to find the correct value. Correct value is equal to 82.5 minus incorrect observation square, incorrect difference square, plus correct difference square. Whichever is the incorrect difference, deduct it, its square, make a square and deduct it, and add the square of the correct difference. So we will get 82.5 minus 3 square plus 7 square. That would be 82.5 minus 9 plus 49. That will give you 122.5. So using this value we will start our final sum. Again write down the formula and then put the correct value, that is the 122.5, into the equation, and that way you will get 1 minus 735 upon 990. That would be 1 minus 0.7424, that would be 0.2576. Round figure r is equal to 0.26, which is the correct answer according to the changed value. So here our exercise 2.3 concludes. Your homework is all the sums of this tutorial twice in your notebook. Please complete these sums because these are important. Next time we will be completing the miscellaneous illustrations of the chapter's final part. That means in the next tutorial we will be completing all the remaining illustrations of this chapter, which contains some unique sums, and that way our chapter will be over by the next tutorial. Till then, my dear friends, keep on revising these things, and that way you will be able to learn it properly. Any doubts, review the tutorials or contact me personally. Thank you. Stay home, stay safe, study hard.